There is a place underwater that makes you forget how to breathe. Not because the water is filling your lungs, but because what you're looking at is so extraordinary, so impossibly alive, that your brain just stops for a second and goes quiet. A coral reef. Some people call it the rainforest of the sea. I want to go further than that. I think it's more like a cathedral. Ancient, intricate, built slowly over thousands of years and home to more life per square meter than almost anywhere else on the planet. And right now, we are losing it. But before we get to that, let me show you what we stand to lose, because I genuinely believe that if more people understood what a coral reef actually is, not just what it looks like on a postcard, but what it does, how it works, who lives there, and why it matters, they would care a lot more. So let's start from the ground up. Coral. Most people assume it's a plant. It's not. Coral is an animal. Tiny, soft-bodied animals called polyps, each one no bigger than a grain of rice, that build limestone skeletons around themselves. Stony coral is the master architect of the whole reef system. It secretes calcium carbonate, slowly, layer by layer, generation by generation, building structures that can take 10,000 years to form. What looks like rock is actually the accumulated homes of billions of tiny animals stacked on top of each other across centuries. That is staggering. The Great Barrier Reef stretches over 2,300 kilometers, and at its foundation is a process that moves slower than we can watch with our eyes. But here is the twist. The coral can't do it alone. Living inside the coral tissue are microscopic algae called zooxanthellae. These algae photosynthesize sunlight and pass up to 90% of the energy they produce directly to their coral host. In return, the coral provides them with shelter and nutrients. It is one of the most elegant partnerships in nature, mutualism at its finest, and it is devastatingly fragile. Because when water temperatures rise, even by just 1 or 2 degrees, the coral gets stressed, expels the algae, turns white, and begins to starve. We call it coral bleaching. It is a reef holding its breath, waiting to see if conditions improve before it suffocates. Now, inside this structure, this ancient limestone city, is where the real story begins. Let's talk about clownfish. I know, you know them. Everyone thinks they know them because of a certain film. But what most people don't know is how genuinely strange their biology is. Clownfish are all born male. Every single one. The dominant fish in any group will transition to female if the existing female dies. She is always the largest, always in charge, always the most aggressive defender of the anemone. And yes, the sea anemone is central to this story. These two species have one of the most iconic symbiotic relationships on the reef. The anemone's tentacles are lined with stinging cells that would paralyze almost any fish that swam through them. The clownfish is immune, coated in a special mucus that disguises it from the anemone's sensors. In return, the clownfish keeps the anemone clean, chases off parasites, and even brings it scraps of food. They genuinely need each other. Damselfish are next, and they deserve more credit than they get. These small, often electric blue or yellow fish are fiercely territorial. Some species actually farm algae. They cultivate specific patches on the reef, weed out the species they don't want, and aggressively chase off anything, including fish 10 times their size, that tries to eat their garden. They are tiny, aggressive reef farmers, and they play a surprisingly significant role in how algae distributes across the reef surface. Then there is the moray eel, which is one of my favorite reef residents because it looks menacing and misunderstood in equal measure. Morays are ambush predators. They wedge themselves into crevices in the reef and wait. Their mouths hang open not because they're threatening you, but because they breathe that way. They push water over their gills by opening and closing their jaws. They also have a second set of jaws inside their throat, called pharyngeal jaws, that shoot forward to grab prey once the outer jaws have hold of it. Alien-level engineering. Morays keep small fish and crustacean populations in check, which matters enormously for reef balance. They are not monsters. They are custodians. The wrasse is another species that runs an operation on the reef. Cleaner wrasse set up what are genuinely called cleaning stations, specific spots on the reef where larger fish come to be groomed. The wrasse picks parasites, dead skin, and food particles off these fish, including from inside their mouths and gill slits. And the larger fish cooperate, holding still, sometimes changing colour to signal they are ready. It is a service economy running entirely on trust and chemical signalling. Goby are small, often overlooked, and quietly remarkable. Some species form partnerships with burrowing shrimp, sharing a burrow where the shrimp does all the digging and the goby acts as a lookout, tapping the shrimp with its tail fin when predators approach. The shrimp, which is almost completely blind, relies on the goby entirely for early warning. Another perfect partnership. Reef ecosystems are dense with these arrangements, layered on top of each other in ways that scientists are still mapping. Seahorses. 3 clips, tiny mention, but they deserve it. Seahorses anchor themselves to coral with their prehensile tails and essentially disappear. Their camouflage is extraordinary. They are ambush predators despite looking like something from a fairy tale, and famously, the males carry the young. Full pregnancy, up to 2,000 eggs at a time. The female deposits them into the male's brood pouch. He fertilizes them, carries them, and gives birth. Nature's way of reminding you that nothing is as simple as it looks. Cuttlefish are visiting the reef rather than permanent residents, but when they show up, they command attention. These cephalopods have chromatophores, pigment-filled cells in their skin that they can control with extraordinary speed and precision. They can produce rippling waves of colour, mimic the texture of sand or coral, flash hypnotic patterns to stun prey. They also have the largest brain-to-body ratio of any invertebrate. They are genuinely intelligent, curious animals that you can observe watching you back. Nudibranchs are the reef's most outrageous art project. They are sea slugs, soft-bodied, shell-less mollusks, and they look like they were designed by someone who had no restraint and unlimited colour options. Neon orange, electric blue with yellow tips, hot pink with white frills. Every one of them a small miracle of biological design. Their vivid colours are almost always a warning. They concentrate toxins from the sponges and corals they eat, storing them in their own tissue, advertising to predators, "I am not worth it, do not eat me." The reef is full of this kind of signalling, colour as language, pattern as communication. The feather duster worm is another one that people walk past underwater and think is a plant. It extends from a calcified tube anchored in the reef, and what looks like a flower or a fern is actually a crown of feeding appendages called radiolars, filtering microscopic food particles from the water. Touch the water near them and they vanish into their tubes in a fraction of a second, responding to the shadow or the pressure wave. Fast, reactive, ancient. These worms have been doing this for a very long time. Garden eels colonise sandy patches near the reef base in large groups. Each one lives in its own burrow and extends its body upward to feed on passing plankton, swaying in the current like a field of grass. Approach them and they retract one by one until the whole colony has disappeared into the sand. It is one of the most visually surreal things you can watch on a reef. Butterfly fish are the reef's most specialised feeders. Many species have elongated snouts for picking coral polyps, worms, and small invertebrates out of crevices the larger fish can't reach. They are often found in bonded pairs, sometimes for life. Their distinctive disc shapes and bold markings may serve as communication between individuals, or as deception, making it harder for predators to identify which end is the head. Form, function, and beauty all tangled together. Fusiliers, antheas, and reef fish in general form the shimmering backdrop of reef life. Schools of fusiliers move in coordinated silver clouds. Antheas, often brilliant orange and purple, hover in great numbers above coral formations, feeding on zooplankton. These fish are not decorative. They are nutrient processors, connecting the open water column to the reef structure, cycling energy through the system in enormous volumes every single day. And pufferfish, round, slow, somehow hilarious, and carrying one of the most potent toxins in nature, tetrodotoxin. There is no antidote. They puff up by swallowing water, making themselves too large and spiky to swallow. Their beak-like fused teeth are strong enough to crush coral and mollusks. They are odd, stubborn, surprisingly curious fish that have been making divers smile and keeping a very respectful distance for decades. This is the reef. It is not a backdrop. It is not a diving location. It is the product of 10,000 years of extraordinary biological negotiation. Every species occupying a role, every relationship finely balanced, every organism contributing to a system so complex we are still learning its rules. Reefs cover less than 1% of the ocean floor. They support roughly 25% of all marine species. They protect coastlines. They feed hundreds of millions of people. And we are bleaching them, acidifying the water around them, suffocating them with runoff, and doing it fast enough that the 10,000-year architecture cannot keep pace with us. The cathedral is still standing, just, but the walls are getting thinner, and the stained glass is going dark. Care about this one, it matters. Follow along, wildlife gets stranger the closer you look.